All right, today we're going to use integration to find the area under curves. Okay, so the first one we're going to do is the area under this x squared graph between the x-rays of 1 and 5. So these are our limits, 1 and 5. We're going to find this area in here. Okay, so to do that, we're going to integrate to the area between 1 and 5. It's going to be x squared dx. Okay, so we do the anti-differentiation first. Okay, so we get 1/3 of x cubed. Okay, and we evaluate this between our limits 1 and 5. Okay, so the first thing we do is we sub in 5. So we get 5 cubed minus what we get when we sub in 1. So 1 cubed. Okay, so we've got 1/3 of 125 minus 1 on 3. So our total units are 124 on 3 units squared. Okay, so this is area. So whatever our units are, we'll get squared. Okay, so let's try the next one. Let's try another one. Get rid of this. What else can we do? Okay, let's consider the graph of y equals x. Well, actually, we're going to do y equals x cubed minus 4x. Okay, so let's factorize this one first. So we take out a common factor of x. We get x squared minus 4, which is of course the same as x minus 2, x plus 2. So using the difference of two squares, you get conjugate factors here. I suppose you call them conjugate factors. All right, so what are we going to do? Let's graph it first. See what this graph looks like. Here's my x, here's my y. Okay, so it's going to go through the origin, +2 and -2. Okay, so, and yep, we don't need to know anything else. Okay, so it's going to go through the origin. Here we go. We know it's a positive cubic, so it's going to look like an upright cubic. So that's -2 and +2. Okay, so how would we find the area enclosed by the graph and the x-axis? So both the sum of both of these areas. Now, when you take the integral between 0 and 2, this gives you a negative answer. So we need to make it a positive answer so we can add it onto this one. So we're going to times this one by -1. So we're actually going to do the integral between -2 and 0 first. So -2 and 0, so to get this area, okay, of y. Okay, and then we're going to minus away what we get when we do this integral between 0 and 2 of y. Okay, so that is going to be our area. Now we could rewrite this by flipping the terminals here. Okay, so flipping the limits, we'll put the 2 down the bottom, 0 on the top, and we'll make that a plus. Okay, so by flipping the terminals, you just get the opposite answer. You get a negative or whatever the answer was. So 2 to 0 of y of x dx. Okay, all right. Let's actually do the integral. What's the integral? We'll do it over to the side. So just to save space, we've got x cubed minus 4x. This is easy. This is equal to 1/4 of x to the 4 minus 2x squared plus c. We don't need the plus c in a definite integral though. So now we're going to substitute this in here for our limits. So we've got 1/4 of x to the 4 minus 2x squared between -2 and 0 plus the same thing. Between 2 and 0. Okay, when you substitute in 0, we get 0. When you substitute in -2, because we get 0 minus 0 is just naught. So -2, what do we get? Okay, so we get well, we're going to minus that away from 0. So we'll get minus 1/4 of 2 to the 4, which is 16, minus 2 times 4, which is 8. Okay. Then let's add it on to what we get here. We get 0 again. So plus 0 minus what we get when we put in 2. Now when we put in 2, we should get the same as when we put in -2, because this is a squared value here. So we should get 16 over 4. So that's 4. Minus 8. Okay, so we get 8. Oh, actually, we get, what do we get here? 8 minus 4, which is 4. We get 4 here, so we end up with 4 plus 4 equals 8 square units. Okay, wonderful. All right, let's get rid of that one. We'll do one more, just for good measure. This one was good just to show you that when you've got area below the axes, you need to multiply by -1 if you want the area. If the question just asks for the integral or the definite integral is allowed to have a negative answer. That's fine. No, let's get to that. Okay, but if you're looking specifically for the area, we want positive area. Okay. All right. What if we had area between two curves? Let's consider two curves. Let's go with y equals x squared minus 2x minus 15 and y equals 2x minus 3. So let's give that a quick sketch just to get a bit of an idea of what that might look like. Okay, so this one factorizes down to x, what are factors here? We've got x minus 5 and x plus 3. I think that's right, 15, negative 2. That seems to make sense to me. I don't have that written down, no. That doesn't matter. Doesn't matter. I think that's right. So, of course that's right. Okay, so that's x, this is y. Let's just sketch it in. So we're going to get this graph. It's going to go through negative 15. Okay, down like that. And I don't know why I did it in red. Let's just do it all in red. 2x minus 3. Something like that. Yeah, not to scale, but this is the basic shape we're going to have. Okay, what if we wanted to find the area between these two curves? Okay, so the first thing we need to know is where these intersect. Where are the intersection points? So let's find them first. We'll set these equations equal to each other. We've got 2x minus 3 equals x squared minus 2x minus 15. Okay, let's make one side equal to 0. So we get minus 4x minus 12. Okay, what do we get when we factor this one? We get minus 6x plus 2. Okay, 12, 6x and 2x, negative 6x, yep, equals 4x. That sounds good. So these intersection points occur at x equals negative 6, or x equals negative 2, and x equals 6. Okay, so these intersection points occur at those x values. All right, so what we can do when we integrate here, we can get the top curve, right, which is the straight line, minus the bottom curve here. Okay, so the area between two curves is going to equal the top curve, which is 2x minus 3. It's on top of the area, minus the bottom curve in those integrals. So this is between -2 and 6. Right, our intersection points. What have we got? We want minus x squared minus 2x minus 15 dx. Okay, top curve minus the bottom curve between the intersection points, and that gives us the area. Okay, so we can simplify this a bit, make it a bit easier to look at. So we've got minus x squared plus 4x minus 3 plus 15 is plus 12 dx. Okay, so now we've got that. We can take the integral first, so we get negative 1 on 3x cubed plus 2x squared plus 12x between -2 and 6. Okay, equals what we get when we put in 6. So we get -1/3 of 6 cubed plus 2/6 squared plus 12 times 6 minus what we get when we put in -2. So I get -1/3 of -2 cubed plus 2 -2 squared plus 12 times -2. Okay, what does this all come out to be? 6 cubed these days. I can't remember, but I've written this down. Luckily, I've done this before. So this comes out to be 72. I think it's 256. I think 256. 6 cubed. 36 times 6. 30 times 6, 180. Yeah, it must be 256 on 3, which is 72. So it's -72 plus 72, so they cancel out. So I get -72 plus 72 plus 72 again. Okay, so I just end up with 72 here because these cancel. So 72 minus what I get here. I get -8 on 3 times negative. So I've got 3 negatives here, so I end up with -8 on 3. Or perhaps I should remove the brackets as I go. -8 on 3. Oh, I can keep the brackets there. Make it +8 on 3. What's this? This is 4. 2's are 8. Minus 24. Like that. Hopefully I've done that right. This adds up to 40 on 3, I believe. Okay, so I've put this on 3. This on 3, yeah. So I end up with 72. Let's not bother with the semantics here. Minus 40 on 3, so plus 40 on 3. I'm running out of space. I end up with 256 on 3 square units. Hopefully all that is in shot. If so, that'll be the end of the video. Good enough.